So guys, this is your last set of notes before we go on vacation, which is very exciting. The beginning of this is literally just a recap of what the assumptions and conditions are. I'm also posting a comparison of the means versus proportions, because that can get a little funky for people if they confuse the two. So just notice that a lot of the assumptions are the same, but a big difference between the means and proportions is that means have that nearly normal condition. So just keep that in mind as we move forward. Okay, the first example that we're going to do for today is looking at just the recap of the bowls of cereal, which again was crazy. All they did is they went through the assumptions and conditions for it. Again, assume that your each independent value is happening within a group, but then the groups themselves are also independent. And then you can look at the data for both of these. They're fairly normal, a little bit skewed right, but they're large enough to be able to move forward, which is good. Alrighty, so confidence interval for the difference of two means. Again, super similar to a proportion and super similar to just a confidence interval for a mean in general. Again, these are your standard errors. So you just have to subtract the means, find your t-score, as we've been doing, and then multiply it by its standard error. So again, your t value you can find in your graphing calculator. So you don't have to do that by hand here, which is kind of nice. Their example of finding the confidence interval is that you can use your subtraction of your means as your first value, right? So that goes in front. So it's literally 6.2 plus or minus 4, which they get the 4 ounces from multiplying the t-score by the standard error. So your standard error, just remember, you can do your square root of your standard deviation squared. So that would be your refilling bowl, which we did already, so I'm just repeating it for you in case you didn't get it, over your sample size plus the 14.7 squared over the sample size, square root the whole thing, and that's where they got the 2 from. It's from the previous question as well. The t-score, when they say from technology, is you can actually just do the t-interval and it'll give you your t-score, or you can do a t-test. So either one of those will work. And your degrees of freedom are based off of the value they just gave you. So you don't even need to really know that, which is nice. Okay, so this is if you're given data for a confidence interval. Again, you want to pretend like this is going in your L1, this is L2. Make a histogram for each one of those, each one. So you want to compare them, make sure you check the normal model. The other thing that you might want to notice is that they changed the window for you, so it just makes it zoom in a little bit better. If you have that range that they had, it's a little bit funky originally, so it helps to have it. Then you can follow the steps in here, so make sure you check L2 under stat test, make sure you're doing the 2 sample t interval, but now you're using data. Okay, so we have L1 and L2 listed. Keep the frequency as 1 for both. Your confidence level is 95%, and then we don't want pooled data. That just means it collects data from other sources, so we don't need that. And then once you hit enter, you have your interval given to you. So that hopefully will make sense to you in the end. If you need to do this out, please do, but you're going to eventually have a chance to do it with other data, so feel free to wait and do it then. Okay, so notice that this is not data, it's just an example with statistics. So I want you to try this one out, pause the video for me, and then when you're all done, I will have the answer. All right, folks, hopefully you were able to figure that out. You actually didn't even need to do very much for calculations, which is cool. So just for letter B, when they give the interval, you have to interpret it. So So just a heads up, randomization should balance the groups of data that you have. So it also helps with independence. It just like helps make it more clear that they are independent. And then letter B, you can say you're 95% confident that after 4 weeks, the mean pinch strength is between 0.04 kilograms and 2.96 kilograms higher. Again, because you're comparing two groups, that's why it's going to be higher here. And then letter C, without data, as we standardly say a lot in these cases, you cannot check the nearly normal condition. Okay, the last type here is going to be your hypothesis tests for the difference between two means. It should look super familiar because it's also really similar to what you've done before, both with proportions and with means in general. So this shouldn't look very new. Again, if you ever need to, you can always make this mu1 equals mu2, meaning the means are equal to each other, so there's no difference. Your t-score you get by subtracting your means dividing by the standard error. And then for technology purposes, we find the p-value with TCDF. And the degrees of freedom come with that. So it's hopefully pretty self-explanatory. Okay. I do want you to try this one. I'm going to have you read through it on your own because I feel like I've been reading through a lot of these for you, and I think you guys can follow the steps. I just want to point out this is where your directions come in, but they give you a lot of the information at the beginning of the problem. So see if you can use these steps to kind of carry through in your calculator. A lot of the information is the same as before, so hopefully you're good to go with that. But check out the final answers again. Pause the video, run through it yourself, and then we're gonna move on. Alrighty, hopefully that went okay. Excuse me. I'm gonna have you read through the just checking scenario. I really like their superhero picture they have going on. Basically because they're talking about grip strength. So they want you to check out what the hypotheses would be for two different grip strength scenarios. The patients are different. Notice that there's difference between the two. And then it says the p-value was less than 0.05, and all you have to do is interpret that. So take a sec, try that out, and I'll have the answer for you. All right, so hopefully your null and your alternate hypothesis looked something like that. Basically, your null means that the pinch strength is the same after both surgeries, but then your alternate is that they're different from each other. So because they didn't specify that one is greater than the other, you just say that they're not equal. For number 5, if your p-value is less than 0.05, hopefully you remember you reject your null hypothesis, which means that there is some kind of difference in pinch strength between the patients. So based off of the results, the endoscopic surgery probably has stronger on average, but we can't be sure unless we do the full test out. And it's not significant enough that it's going to be something we can see here because we don't see all the data, but you guys would be able to interpret that if you had all of the information at the beginning. Alrighty, so this is actually our last question, which is kind of weird because there's another page, but the last page is actually posted on Classroom separately because it's a good chart that compares the two sample proportion and the two sample means. So if you're having trouble differentiating between the two, it kind of helps you figure out the difference between them. It's nicely organized too, so it'll help you for the assessment we're going to eventually have next week. We're going to practice quite a bit with this first, and then towards the end of the week we'll have a little assessment on it. But the last question is actually all done out for you, so I want you to notice what they use. Remember, if it's an alternate hypothesis that is a does not equal 0, it's a two-tailed test, so that's why your probability at the end is going to be multiplied by 2. If you forgot that from the previous section, just make sure you're aware if it's a right or a left-hand tailed test, you actually don't need the 2 times the probability. If you're still having trouble entering in some of this in your calculator, a lot of it is the same stuff over and over, just for different types of data. Please join into my office hours, but I'm going to again have you just read through the scenario. Notice when you have your hypothesis test, you really do want a normal model just to show that visual to help people see what it looks like. But go through this on your own. Again, that last page, but feel free to check that out on your own. And the textbook homework that is due, you should be able to do all of it now. And I tried to make it pretty short so you're not going too crazy. All right, if I don't talk to you in my office hours, have a wonderful weekend, and I will talk to you on Monday. Is just the comparison chart. It's really nice to be able to see the difference between the two scenarios.